Today we're going to be talking about proofs, right? But in the context of proving that triangles are congruent. So your notes should look like this. I accidentally printed out the regular geometry version of this lesson for you guys. For honors, the proofs will be not as filled in, right? So the expectation for honors, and this is what's on the homework. Like the homework doesn't have any guidance, like with the filled in stuff. But your expectation, or the expectation for honors, is that you guys will be able to complete these from scratch, or have one side filled in and then fill out the other side. You're not going to have very much of the back and forth, like you're going to see in the notes. Unfortunately, I forgot to fix that. But the proofs are the same regardless, so we're just going to work through it in this format, and then we'll practice in the homework how to create them from scratch. But these proofs are going to be very different from the ones that we've done before, right? There's very rarely going to be any substitution or addition or subtraction and division and stuff like we've used like that. There's hardly any substitution. We don't really use the segment addition postulate that much, except for overlapping triangles sometimes. This is more like taking the process that we've been doing in the past two lessons, where you look at a picture, you add information that you can, then you explain why. And at the very end, you tell me why the triangles are congruent. So this is more true to a proof of just listing out your thinking process that we've been doing in the past. Do you guys remember when we were first introducing that, and I told you guys it was a good idea to write down why you added a marking to the diagram when we were first doing that? I did that as a suggestion to prepare you for proofs, because that's essentially what this is. When you add a marking, you explain why you did that. If you add another marking, you explain why you did that. And then once you have all the information, you just tell me which rule you used to show the triangle is congruent. So these proofs are going to be much more straightforward compared to the ones we've seen before. We're going to be using any of those rules that we've talked about so far. So we've talked about all five, so any of them are up for grabs, these proofs. We're also going to be introducing another rule called the CPCTC. I believe I included all of these and this on that little piece of paper I gave you, the reasons for proofs thing. CPCTC is an abbreviation. It stands for corresponding parts of congruent triangles are congruent. That's a lot of words, so we abbreviate that. There's a little bit of a tongue twister, but CPCTC stands for corresponding parts of congruent triangles are congruent. We use this for a second type of proof we're going to talk about. Once you decide that the full triangles are congruent, shouldn't every little detail, like all the sides and the angles, be congruent? Ones that you didn't previously know, but if you prove that the triangles are congruent, you can fill in all the other angles that were blank, or all the sides that are blank, saying they're congruent. So we use this rule to do that. Once we know the triangles are congruent, we know everything about the triangles are congruent. So I have two different kinds of proofs that I'm going to teach you guys today. I like to refer to them as big picture proofs and small picture proofs. So this first type is when you're asked to prove that full triangles are congruent. So you're going to say prove that triangle blank is congruent to triangle blank. I call this a big picture proof because you're trying to prove that the whole triangle, or the big triangle, is congruent to the other entire triangle. This one right here with the second arrow, this is where you're trying to prove that part of a triangle is congruent to part of another triangle. I call this a small picture proof because you're zooming in, you're shrinking the picture in the format of what you're looking at. You're zooming in on a particular part of the triangles, so you're kind of shrinking the image that you're looking at. In order to do that, you first have to prove that the whole triangle is congruent. So that means you have to use this first. And then once you've decided that the whole triangle is congruent, you're going to follow up with the CPCTC rule. So once you've decided that the big picture, everything about the full triangles are congruent, you can zoom in on a specific detail and say that those are congruent because of this rule. Right? So those are the two different kinds of proofs that we're doing today. This one is going to be exactly the same as these, but with this extra step on the end. So to illustrate that, I have two proofs here. All right, this one right here is an example of a completed, it's already completed, so we're not going to go through it. This is an example of a completed big picture proof. So you'll notice in the proof statement, I'm trying to prove that full triangles are congruent. So that's why it's big picture, as I refer to it. And you'll notice how I went through the structure here. I always start with given, that's the same as usual. And then I go over to the picture and I notice that I can add this, right? Just like we've been doing in our previous lessons. If you know you can add something, you do so. And then I went ahead and I wrote that as a congruency statement. When I added the reflexive property here, I was saying that this segment was equal to itself, because it's one per triangle, but it's coinciding. So then I would say that AB is congruent to AB by the reflexive property, and that was enough to say that the triangles were congruent by side, side, side. So all that these proofs are is just listing out your thinking process as we've been doing for the past 2 lessons in the structure of a proof. Okay? And then this one right here on the bottom of the page is an example of a small picture proof, which instead of proving that the triangles are congruent, you're trying to prove that specific angles within the triangles are congruent. In order to do that, you need this first. In order to say that parts of triangles are congruent, you need to say that the full triangles are congruent first. So this is the exact same copy as what you guys just saw. It's the exact same picture. You notice you needed that. You have the reflexive, you know the triangles are congruent. And then for a small picture proof, it's just this one extra little line added on. That's the only difference. Once you have the triangles are congruent, you just slap on the piece specific to the triangles that you're trying to show is congruent, and then your reason is CPCTC. Alright, so they're pretty straightforward. We've already been practicing how to know if the triangles are congruent or not. So we've already been practicing that for the past 2 lessons. So all that's new here is being able to articulate it in the format of a proof. Okay? So that's what we're going to practice. As you turn the page. Alright, here's the first one we're going to start with. Now the way that I want you guys to go through these proofs is very similar to what we've been doing before. You're going to start with the given, and then you're going to go look at the picture for the majority of the proof, and then come back and see if you can add anything. Alright, so this proof is based on the visual a lot. Right? It's primarily based on the visual and doing the questions like we've been doing in the past 2 lessons, and then coming back and writing that down. So the first things that I know, you can write down the given statement just to get that out of the way. So I know that AB is parallel to DC. They've already put the marking in for me. I also know that AB is congruent to DC. So they put that marking in for me. If they don't put the markings into the picture already, you'll have to do so yourself. Alright? So I have the markings and I write given. Now, forget the proof for a second. Stop looking at the box. We're going to do the questions like we have in the previous 2 lessons. If I asked you if these triangles were congruent, how would you approach this question? If I just said, are they congruent, how would you approach it? Anybody, what's an idea? Add reflexive? Is that it? There are parallel lines. What would I do with the parallel lines? Alternate interior. We have the Z trick. Gives me these 2 right there. Okay. So I use the parallel, I use the reflexive. Is that enough? Would these triangles be congruent? What rule would I use? Side, angle, side. Each triangle has 2 sides with an angle in between. So you just check to make sure both triangles have that side, angle, side, angle, side. So we're good. So what you guys just did is the proof. Now you just have to write it down. So for you guys in honors, we had 2 different things that we found, the angles and the reflexive. This will be blank, so you guys can pick which one you want to mention first, but for our purposes for this proof, they've already set where they want this step to go. So what did I get? When I use the alternate interior angles theorem in this picture, what did I get? Not angle C is congruent to angle A. Yes. Okay. DCA. Angle DCA. Remember from lesson 1, it's important that you name the angle correctly. So if I start with DCA, how would I name the other one? DAC. The reason why I can't just use A and C is because there's more than one segment coming out from A and C, so I don't know what angle you're talking about. Alright, so you have to use 3 letters. And again, ordering when you're naming stuff, and I made a bunch of typos in here, so when I find them, I'll make sure you guys can correct them, because I wasn't paying attention, but when you guys are writing out the order of the angles or the segments, you have to make sure that the letters are in the correct order. Alright, so cool, we got the angles. What else did I add to the picture? The reflexive. What does that give me, though? Like, how would I represent that? No. CA. If you are not sure about how the letters should be arranged, look at this. Remember how the names of the triangles will always be set up with the corresponding angles, right? So if you're ever confused on how to name them correctly, and they have this provided, use that. Whatever context it's in, solving congruency questions, proofs, if they give you the names of the triangles, it's going to be set up for you. So use that as a guide for naming them correctly. If they don't provide this for you, so if it's a small picture proof, they're not going to mention the names of the triangles. So if you don't have that visual to help you, you have to look more closely at the visual. Do you guys see how we labeled this angle with the single mark to say it was congruent? A is down here, right? That's angle A, or part of angle A. Where's the single mark angle in the upper triangle? All the way over here. So that means C and A are corresponding. So when you name the segments, A and C correspond, and then you have to switch the order here. So whenever they have that Z trick, just in order to remember this, whenever they have the Z trick, these letters will switch every time. So if you have parallel lines with that, using that Z trick, then you have to switch the orders. It's just how it works out because the triangles have been reflected. Okay? So that's something you need to remember. Be careful with the letters. And then how did I know that? Nope. How did I know this? Right here.
Reflexive.
The reflexive. And then once I had that information in addition to what was already provided, how did I know that the triangles were congruent?
Side angle side.
There you go. That's how these proofs work. Okay. Questions on that one? Alright, this next one right here. Again, just set up the given. Either write this down or write given or both, doesn't really matter. But once you set the given, stop looking at this. Alright, stop. Find all the information you need first, and then you can go back and fill out the body of the proof. So we're just going to take the givens that we know, add them to the picture, and then start generating some ideas. So the first thing that I know from the given is that segment BM is perpendicular to segment DC. How could I illustrate that in the picture? I know, but how do I illustrate perpendicular? Right angles. Just one?
Two.
You want two of them, right? Because perpendicular, the definition of perpendicular means it's intersecting lines that create right angles. So that implies right angles at every part of the intersection, okay? I also know that M is the midpoint of AC.
Eight.
Say it one more time. A to M and C to M. Good use of the appropriate ordering. A and C are corresponding, so when you name the segment, it should be AM and CM. So just get used to naming them correctly in your head so it comes out more easily on paper. Those are the two givens. Is there anything else that I can add just by knowing, like we've been doing before? The reflexive. I don't have any vertical or parallel or isosceles, so reflexive is the only marking I can add. Is that enough to show that these triangles are congruent? Using what rule? So once you've made that conclusion, you've proved to yourself why they're congruent. Now we're going to go and fill out the body of the proof. So we have the given here, and then their next line for this proof is that angle 1 and angle 2 are right angles. How did I know that? Definition of perpendicular. That was my first given, and that's the first word that I recognized, so I used that to get the fact that they're right angles. Now when we've done this before with right angles and we're trying to say that they're congruent, we've done this whole process where we then say angle 1 and angle 2 are equal to 90, and then we set them equal to each other with substitution. You can still do that if you want to, but I actually found a shortcut that is relevant to this kind of proof, but you can technically still apply it to ones we've done before. I don't have it on the reasons for proofs page, but if you want to add it later, it's called the right angle congruence theorem. Basically says that every single right angle that exists is congruent to every other right angle that exists. So instead of doing the whole thing where you say angle 1 is equal to 90, then angle 2 is equal to 90, and then set them equal to each other because of substitution or transitive property, you can just go straight here. You know that the right angles, therefore they're congruent, using the right angle congruence theorem. Feel free to use the other method if you want to, because you're familiar with that. It still works, it's still valid, but I just wanted to introduce this to you in case you would like to use this. You can go straight from the fact that they're right angles to saying that they're congruent based on that theorem. Okay, so feel free to use that or not. You can go use the other method too. But we needed the fact that they're congruent because in order for it to be side angle side, the angles themselves have to be congruent to each other. So we had to include that little line there. Okay? What did I get from the definition of midpoint? AM is congruent to CM. And again, make sure you're really careful naming the letters correct order, and you can use the names of the triangles, or you can just visually see what parts are corresponding. Alright, what else did I need? I took care of the givens so far. What else did I add in? The reflexive property, but what did that give me specifically in this picture? Do you have to switch the letters? No, you don't. Look up here, they don't switch. And it wouldn't make sense for them to switch either, because if you look at the diagrams, doesn't M represent both of the right angles? So shouldn't M be corresponding to itself in both because it represents the same angle? So use the visual and the name to figure out what's corresponding. This one doesn't have the parallel line Z. There is another situation where you would switch the letters, the Z and that other one that'll show up in a second. But for this one, you don't have to switch the letters. Just be very careful looking at the corresponding. And again, this was reflexive. And how did I know the triangles were congruent?
Side angle side.
Great. Questions on that one? Okay. I'm going to do this last one a little bit faster. We can move on to the more interesting ones. Alright, so we have our given. I'm just going to write that down, get it out of the way. Then I'm going to actually use the givens to add information to the diagram. So what I know so far, and this is supposed to say segment, that's my fault. So segment RP bisects angle QRS and QPS. What does it mean to bisect? And what is being cut in half? Two angles. Two angles. So when I cut an angle in half, the two halves should be angles still, right? My other two classes were having so much trouble. They were trying to say that QR is equal to RS. Okay? No. When you have an angle and you cut the angle in half, the result should be two angles, okay, that are equal. So if I cut QRS in half, what do I know? Angle 2 and angle 4 are congruent. Those are the two halves. If it also cuts QPS in half, what do I know? 1 and 3 are congruent. Those are the two halves there. Alright, so cutting an angle in half will result in angles. Cutting a segment in half will result in segments. So please don't mix the two. Alright, anything else I can add? The reflexive. That gives me what rule? Angle, side, angle. So now I just need to enter that into the proof. Alright, so I noticed this. What was the first thing that I then said? Angle 2 is congruent to angle 4. And remember, you guys can say this information in whatever order you want. I'm just going through the stuff that we noticed. So angle 2 is congruent to angle 4. Why did I say that? Definition of bisect. Alright, what was the other thing I noticed? Based on the given. Nope, based on the given first. Okay. Yeah, typically you go through the given stuff first and then add in the stuff that you noticed later. So angle 1 is congruent to angle 3 because of the definition of bisect again. You can definitely use the same reason twice. This is valid. And then they've provided for us this extra step that PR is congruent to PR because of the reflexive property. And notice here I didn't have to change the order, right? You guys see how I put the double mark here and the double mark here? P is corresponding to itself in both triangles. So again, you can visually see that you don't need to change the order. So PR is congruent to PR. And then why do I know the triangles are congruent? Angle, side, angle. Alright. Let's take a look at this one. So those first three that we were doing were big picture proofs. They're where I was trying to prove that the full triangles were congruent. This one right here is different. What am I trying to prove? That parts of triangles are congruent. So I still need to do triangle is congruent to triangle. I still need to prove that first. But once I have that, I only need to tack on one extra step, the CPCTC step. That's the only difference in these proofs. You first show that the triangles are congruent like we've just been doing, and then you put this extra step on there. Okay? So always start with given. Blah. Write that down. Now we're going to use the givens and start adding extra stuff into the picture. So they've already put the parallel markings for us into the picture. If they didn't do that, you'd have to do it yourself. But they have. So what would I do? What would I add? What markings? All I know is that these are parallel and these are parallel right now. You can use, since they're numbers, you can use numbers. So using which set of parallel lines? Okay, so you should notice that with these sets of parallel lines, you have a diagonal transversal. So what would I know? An angle 3 and 2. All right, is there another set of parallel lines that I could use? I have these guys right here. What transversal would I want to use? DB again. I'm going to use the same transversal, but for the different parallel lines, and they're going to give me different angles. So with this Z, or this zigzag, what two angles would be congruent?
1/4.
Make sure you remember when it's a different set of angles, you have to use a different number of arcs for the hash marks. So I already used a single, and now I add the double. Is there anything else that I can add?
Reflexive.
Okay. If I do all that, how would the triangles be congruent? Alright, once you've gotten to this conclusion, we're going to fill out the proof and then add the extra step of the CPCTC at the end. Yes.
Why can't these angle 4 and angle 1 are congruent with like A, B, and C?
Because those are not an angle relationship with A, B, and C, D. In order to create angle 4, not only do you need this line right here, you need this one to create angle 4. So you have to use the other set of parallel lines. Alright, so start telling me stuff I know. What do I know? What did I find out from the picture? I already know they're parallel. From that, what did I get? Angle 2 is congruent to angle 3. Why? We use alternate interior angles. So alternate interior angles theorem. What else did I find out? Angle 1 and angle 4 were congruent. Why? The parallel lines give us the alternate interior angles, so we can use alternate interior angles theorem again. So it's the blue angles and the red angles. What else did I find out? Say it one more time. Okay. This is another situation where you have that diagonal. The triangles have been reflected so that the alternate vertices are corresponding. So D corresponds to B. So in this situation, you will have to switch the letters. Now, in this proof, you don't have the names of the triangles to help you. Remember in the previous 3, you had the names of the triangles written there, so you could use that as reference. For small picture proofs, you do not have the names of the triangles. So this is where you have to rely very heavily on the picture to figure out what parts are corresponding. But we practiced that on day 1. So when you add the markings, you just have to make sure that you're looking to see what's corresponding to what. In the lower triangle, this angle right here corresponds to this one. So D corresponds to B. So that's why you guys have to switch the order when you're naming them. So again, use the visual to help you figure out what's corresponding. And this was what property? Once I had all that, I had 2 sets of angles and 1 line in between. What can I conclude? Well, I'd say the triangles are congruent, right? Triangles are congruent, and then you follow up the CPCTC. So I'm going to have to name the triangle. Okay, so if I start with the triangle on top and I call it ABD, and remember, this is your personal preference, so you get to name it however you want. Once you name the upper triangle, this way you have to name the bottom one in the appropriate order. What corresponds to A? C. In the lower triangle, what corresponds to B? D. And in the lower triangle, what corresponds to D? E. So this is how you name the triangles, and that was because of angle side angle. Right? Now, this is to prove that the triangles are congruent. If you want to do your small picture proof where you're zooming in on these 2 segments right here, what would your reason be? C, P, C, T, C. Corresponding parts of congruent triangles are congruent. C, P, C, T, C. try that one on your own, please. Alright, you can explain how I would do this one. Can you walk me through it? Hopefully you guys at least know how to start it, right? Okay. It's not going to give you much credit, but at least you should know that part. Now what?
I said FT equals GP and KP.
Okay, we use the whole bisect idea, right? What else? To be a little bit more specific than just angle. Okay, so when you did all that, that was enough to show the triangles were congruent, right? What method? Side angle side. So again, you're going to go into the body of the proof and you're going to write that down. So just like Tatum said, we could start with FP is congruent to GP. Make sure you name the letters in the correct order. F and G are corresponding and they both go in like that. So that was the definition of bisect. Alright, we did the same thing with the other line. We said that KP was congruent to JP. Same thing. And then we had our vertical angles, right? So FPK is congruent to GPJ, or KPF, however you name the equal. Just make sure you name the other one in the correct order. And then what would I write here? You could say vertical angles theorem, or you could write out the actual what the theorem says. Vertical angles are congruent. Either one is fine. Vertical angles theorem, or the statement of the theorem, vertical angles are congruent. And then how did I know the triangles were congruent? Like a different order? Yeah, as long as you have all the steps, it doesn't matter what order they are.
Do you need to have a little like squiggly thing?
Yes. So this is a good question that Katie's bringing up. For congruent triangles, we're not talking about their measures. We're talking about congruency of segments and angles. So there should be no equality in here. It should all be congruency. So make sure you guys are writing congruent markings instead of equal signs, because we're not talking about how long they are as numbers or values or stuff like that. We're talking about comparing them as congruent. So please make sure you're using the congruency symbol in these proofs. Alright, now we're getting into the realm of ones that are more from scratch. This is more like what you guys are going to be expected to do. Did you have a question? Because of your markings, you see how you did a double marker and double marker. You can see that the double marking would here used to be a double marking. They correspond. Alright, so for this one right here, this is a small picture proof. So what do I have to show first? No. In general, in order to get here, what do I have to first show? Yeah, that the triangles are congruent. So my first mission is to show that the full triangles are congruent, and then I can finish with the CPCTC stuff. Okay? So, just like we were doing before, write your given just to set the stage, and then we're going to put everything into the diagram and see what we have to work with. Alright? So the first thing that they say as a given is that segment EN bisects angle KEV. How is that significant? Again, what's being bisected? An angle. So the result should be angles, right? Can you get the door? Alright, so what angle is being bisected? KEV, which is right here. So if I cut that in half, I would have two congruent angles. Which two angles? KEV So remember, whatever's being bisected, the two parts should be like that. So you can't divide an angle in half and get congruent segments. That doesn't make sense, right? So when you cut an angle in half, you have two congruent angles here and here. This line is just slicing the full angle in half. I also know that segment EN is perpendicular to segment KB. So how do I illustrate that? Okay. So we have two right angles. Right, perpendicular definition tells us we have all the right angles around the intersection. Is there anything else I can add? Reflexive. So with that, why would the triangles be congruent? I promise you side angle are not the only two that they use. They're just the two most common. Alright, so now we're just going to go through the proof and explain. Alright, so what's one of the first things you guys saw or extrapolated from the given? So angle KEN was congruent to angle VEN. It's the first thing that we saw because we were reading the givens in order. Yes? Why do I know that? Definition of bisect. Alright, so that was the first given and we took care of that. What do we get next? When you guys saw this next given, what was the first thing that you thought? Right angles. So how would I express that within the proof? Okay, so KNE, this angle right here, KNE, and angle VNE are right, should have written smaller, sorry, are right angles. Just like we saw in the previous proof that used perpendicular within the given, once you see that they're perpendicular, you follow up by saying that they're right angles because of the definition of perpendicular. When you guys see that symbol or you see the word perpendicular, that should be the first thing that comes into mind. Because they're perpendicular, I have right angles. Remember I taught you guys not to do the straight to 90 degrees. It's not what you do. You go straight to right angles. Okay? Now from here, just like in the other proof, you guys could say, now that they're right angles, you could say that this one's equal to 90, that one's equal to 90, and then you set them equal to each other in substitution. But that's 3 extra steps, right? You can just proof where you can just say angle KNE is congruent to angle VNE using, what was that new one called? Right angle congruence theorem. Right angle congruence theorem. Alright, cool. So I have this angle taken care of. I have this set of angles taken care of. What was the other thing I needed? Okay, and that was the reason. What does that give me? EN is congruent to EN. You don't switch the order in this one, because if you look, N represents the right angle in both triangles, so N corresponds to itself. So you don't switch the order. It's just EN is congruent to EN. Remember, the most often situation where you guys switch the orders, again, with that diagonal, with the parallel lines. Okay? There's another situation that's about to show up. I can't remember which proof it is, but there are really only 2 situations where that happens. And again, this is reflexive. Oops. Was that enough to show that the triangles were congruent? Yeah, we already concluded this, right? So your next step, even though it's a small picture proof, again, you have to prove the triangles are congruent first. So now I'm going to name the triangles, say they're congruent. So how do you want to name KEN? If I name the first triangle KEN, that means you have to be careful how you name the other one. V, what corresponds to E? E still. And then what corresponds to N? N. So KEN, VEN. And how did I know that those were congruent? Angle, side, angle. And then am I supposed to stop there? No, they wanted me to prove that these specific parts are congruent. So my last step, I apologize for writing so low on the board. My last step would be to say KE is congruent to, and this is one of my typos, Sorry, that's a typo. That's supposed to say VE. That's my fault. Alright, I didn't have the corresponding letters in the right order. My bad. I do that a couple different spots in the notes. This is the first one I've caught so far. In today's lesson, I found all of them before. So KE is congruent to VE using what rule? CPCTC. Okay. Questions on that one? Remember, you guys have to be extra careful about the perpendicular, that you mentioned right angles first. And then you can either bring in the 90 and do substitution, or use the right angle congruence theorem. Okay? Okay. Yes. Alright, this guy is interesting. We have a lot of givens. Alright, we have a lot of givens to work with in this one. So we're going to have to be careful, paying attention to what we're doing. When you guys are creating proofs for yourself and it's completely blank, you can either put all the givens at the beginning or you can spread them out as you use them. When there's this many givens, you probably shouldn't write them all at the beginning. I'd recommend writing one of them and then writing what you would get from that and then spreading it out. But you don't have to. If you want to just put them all at the front, feel free, and then just add in the other stuff later. It's really up to you. Alright, so this is all my givens. The first one right here says that C is the midpoint of AE. So C is right here. It's the midpoint of this full segment. So what does that give me? Yes. So A and C are corresponding. So when you name the segment, you can go AC and then CD. You can just follow along the pathway of the segments and name them. Alright, I know that AB is perpendicular to BC. How do I represent that? Right angle, okay. Then I know CD is perpendicular to DE, the right angle. And then lastly, I know that AB is congruent to CD. And they've already put that into the picture for us. Okay? So now that I have all that in the picture, what rule would I use to say that the triangles are congruent? HL. Alright, this is HL. Is this a big picture or small picture proof? This is a small picture proof. So first show that the triangles are congruent, and then we're going to wrap up with this step right here. Okay? So I'm going to go ahead and write down what we know. So all the givens either up front or spread out. My first given was the midpoint idea. So what did I get from that? AC was congruent to what? CE. And that's the correct ordering for those. And again, that was the definition of what?
Bisect.
No, they don't use the word bisect. Midpoint. Don't invent new words. Use the one that they have provided in the given. So the definition of midpoint gives me that information. Alright, so if you wanted to spread out the givens, you would write this here, then this, and then the next givens could be the perpendicular ones if you wanted to spread them out. So if you write the perpendicular givens, what did I get from this? Yes, from both of these together, I got that angle B and angle D are right angles. You can use more than one given together if they're very similar. So those two givens, the perpendiculars, they give us angle B and angle D are right angles. Now, what would I get for the reason? Definition of perpendicular. Then what? Okay, so you can follow up with this and say that the two angles are congruent if you want to, like we were doing before with the perpendicular. But for HL, you don't necessarily need that that the angles themselves are congruent. So you can either include that step or not. It's really up to you. But in either case, whether you state that the angles are congruent or you just go straight to HL because you have the two legs and the hypotenuse, you would say triangle, you just call it ABC, is congruent to what? And what rule do we use?
HL.
I wanted to stop for the proof. What else do I need? Or how do I finish the proof? Okay, so BC is congruent to DE using what rule? Alright, questions on that one? Okay. So, for you guys specifically, that's where my regular geometry kids would have stopped. For you guys specifically, you also need to know how to write a proof for the overlapping triangles. It's the same exact same process as before. Separate them, add the information, they're congruent, write it down. Right? They can be slightly more complicated though with them being overlapping. This is where the second addition postulate might need to come in. You might need to use some of those other properties that we've seen before in proofs. So they can be a little bit more complicated, but it's the same process that we've been practicing before. Another complication that can come into play is if it's a small picture proof. When we've been seeing the overlapping triangles, I specifically told you what triangles to prove are congruent. And that made it easier for you to redraw, to kind of zoom in on what you needed to know about the picture. This one doesn't tell you what triangles need to be congruent. It's a small picture proof. So you guys have to figure out on your own, what two triangles do I need to show are congruent in order to get these two angles to be congruent. So that's one of the things you guys will need to kind of figure out here. So if I'm trying to prove, I'm going to use my marker to show the angles that need to be congruent. Hold on. Alright, so I'm trying to prove that PQT, which is right here, I'm just going to draw little dots to illustrate, is congruent to PVR, which is right here. Alright, so I'm trying to prove that those two are congruent. So what two triangles would I need? Okay, one at a time. Hold on. Which one? What's one triangle I would need? This one? Congruent to what? If I show that those two triangles are congruent, would that give me the little corners that I need? Okay, so you have to do that little analysis first. Now we're going to do the process like we've done before. Let's redraw the triangles separate from each other. That's the blue one. And that's the red one. Okay, draw them separate. And then we're going to add the givens and go from there. Okay? So I know that T is congruent to R. They had added that into the picture for us. I also draw that into the separated pictures. I know that PQ is congruent to PV, like this. That's what I'm given. What else do I know? Think back to what we used to do with these problems before. Okay? So they both have angle P, right? That's a reflexive for an angle. Both triangles have that letter in common, so that means that they share the angle right here, where they're overlapping. So what rule would I use to show that the triangles are congruent? No, the full triangles are congruent by what rule? Angle, side. Once I've proven that the angles, the triangles are congruent, then I can say the specific angles are congruent. Alright, so now we're just going to go into the proof and write down everything that we discovered. So I know that angle T is congruent to angle R. I also know PQ is congruent to PV. Now the reason why I'm writing both givens at the same time is because I have so few boxes. But again, when you guys have more space and it's your responsibility to create the proof from scratch, I'm going to give you plenty of space to either write the givens together or separate them. So it's really up to you. Why? But this angle is not inside either of them. These two? That's not fully inside of the blue. Yeah, it has to be one of, see how there are three corners for the blue? It has to be one of those. So those vertical angles aren't going to help. Alright, I had my givens. What was one of the things that I know after the given? They're reflexive. So angle P is congruent to angle P. Why? Reflexive property. I already said that. Right? I used the two things I already knew and I added this in, and then what did I conclude? The triangles are congruent. So again, it's your responsibility to name them. So let's say you name the first one PVR, or however you want to. But if I name it PVR, how would I name the other one? PQT. And again, you have to use the visual there to figure it out. So V and Q are corresponding, and R and T are corresponding. And what rule did I use?
How do you know what to just do with P and then what to do with PPR?
Like 3 letters. If you only have 2 lines coming out from one angle, then there's no ambiguous confusion on what angle you're talking about. If I was like talking about angle S, see how there's 1, 2, 3, 4 different segments? If you just say angle S, I don't know what you're talking about. But for P, there's only, boom, 1 angle. So I know what you're talking about. So it's when you have multiple segments coming out from a vertex that you can choose 3. Alright, once I know the full triangles are congruent, how do I know that these specific angles are? B, C, D, C. Alright, make sense? Alright, we got one more. Okay, this one I feel is like the more complicated one. There are 2 ways to prove this. I really regret having it set up this way because I would have preferred you guys explore how to prove it on your own, because there are 2 different ways. But I'm just going to go through the one method that's here. But the expectation for you guys is to see your own way, go your own way. So on the homework, it's completely blank. You can create your own setup for the proof and all that. The answer key is the way that I thought about it. It's hard to write an answer key for proofs because there's so many different ways to prove things. But if you're curious on whether your proof is correct or not and it's different from the answer key, just come ask me and I'll look at it. Alright, so for this one, they've told me what triangles to look at. So I don't have to do any of that, figuring out what kind of triangles they are. So the first thing I'm going to do is redraw them. So I want QDA, which is right here. QDA. And UAD, which is right here. Here we go. So you're going to draw the 2 triangles just like we've done before. Now this one is going to be another situation where you have to put markings into this picture before you can transfer them over here. So we're going to have to be careful with that. I know that QD is congruent to UA. So that's one thing I know. Transfer that over to the separated triangles. I know that QR is congruent to UR, and that RA is congruent to RD. This is what I know. So I don't know anything right now about QA, because they haven't specifically told me that QA is congruent to DU. But can I get that? We've talked about this before, yeah?
QA equals QD because
Why?
question.
Okay, so I can say that the full lengths are congruent because the addition of these 2 segments and those 2 segments are equal, right? 2 marks plus 3 marks should be equal to 2 marks plus 3 marks, right? That's the segment addition postulate. We're going to have to be more specific how we write that in the proof, but in our minds we can see that because these 2 are the same and those 2 are the same, and you add them together, they're the same length. So I can say that these 2 segments are congruent. I'll have to get there a little bit more specifically within the proof, but I now know that those 2 are congruent. What else? You guys see the DA, both of the triangles have that common side. So I can say that DA is congruent to DA, and what rule would I use? Side, side, side. Now there is actually another way that you could prove this. If you notice that this triangle right here in the bottom is isosceles, you could use the base angles theorem to get this angle is congruent to this angle, which would show up here and here. You could also use side angle side. So there are 2 ways you can prove this situation, but I'm going to go with the side, side, side version as we're filling in the proof. Okay? Alright, so I had my given. So this proof has the givens spread out. So this is what it would look like if you were to spread out the givens. So the first thing that I wrote was this. Okay, cool. That was my first given. Now I want you guys to tell me what we know about the segment addition postulate. How can I use the segment addition postulate to move forward? Yes.
QR plus AR equals QA.
Good. So I needed to define what QA is. If I'm going to use QA in a second, I need to define what that is. So I can take the two parts, the QR and the R or AR, the things that I have in the givens, right, that I'm using. I add those together and set it equal to QA. What other equation could I write? Yeah, I can do the other one, add its two parts, define its full length. Right? The reason why I need to do this is because I have all the little individual parts in the givens. So I have to use this definition here with the segment addition postulate to define the full lengths. Right? So once I have these two, and you can feel free for your own proof to write them on different lines if you want to. I just was lazy and wanted to write the reason one, so I put them together. So now I'm going to bring in these givens. How can that help me work with this and add these into the question to get these two equal to each other? What do you guys think I would do? I know all these congruencies. With the way that the equations are written right now, can I automatically say QA and UD are the same? Shouldn't both of these be the same for me to say that those two are? Remember our substitution rule says that if two different things are equal to the same thing, they're equal to each other. So I need to somehow get one of these equations to change so it looks like the other one. Can I do that? How?
QR equals UR.
Okay, so QR equals UR, so what can I do with that?
Substitute.
You could swap it out. Instead of writing QR in this equation, what could I write? I could write UR. So if you want to draw a little illustration, I'm going to draw a little arrow here. I'm going to rewrite this equation using these congruencies. So instead of QR, I'm going to swap out for UR. So now I have the first part the same. Then what? Doesn't AR equal, sorry, RD? These two are the same. So instead of writing AR, I can write DR or RD, however you guys want to write it. Doesn't really matter. Right? So now I've taken this first equation and using the given congruencies, I swapped it out. So now do you guys see how these two equations are the same? So what can I say about UD and QA? I'll do the reason in a second, but now that these two equations are the same, what can I say about this and this? They're equal to each other. UD is congruent to QA. And both of these are the reflexive property. I'm going to have to scroll up in a second, so give me a second. Right? Then I'll erase it. Right? So this is really where the complicated kind of part of proofs comes back into the picture for these. You have to use the segment addition postulate, and in our head, we knew that 2 plus 3 equals 2 plus 3, therefore they're congruent. But the way that you write that looks more complicated. Right? So you set the equations using the segment addition postulate, and then you start substituting the little pieces so that the equations look the same. And then you can say that these two are equal. Yeah.
So here, it's like substitution.
Oh, I'm sorry. Why did I was rushing. I'm sorry. You're right. It is substitution. That's my fault. Sorry, guys. I knew I was going to erase it in a second, so I was rushing. Yeah, you're right. That's substitution. For this step, I substituted the little parts in. And then for this step, I substituted the full equation so I can get the two results to be the same. We've done that kind of stuff before. It's just been a little while since we've done that. But that's how you would express the segment addition postulate in your head. Now I'm going to have to scroll and erase it all. So does everybody have that written down? So you can scroll and reset. Okay. If it'll let me. Alright. So I no longer can see the picture, but you guys have it on your paper. So we're now here. Here, right? Okay. So now that I know that I have those two sides are the same and those two sides are the same, what was the other thing that we added in? DA was congruent to don't think you need to change the order. Can't remember. Hold on. It might be the case, but I just erased the picture so I don't remember. Yes, you do need to change the order. So when you look at the diagram, when you look at the way that you guys drew the picture, you can see how the single and the triple lines meet with the markings. Wherever those two lines meet, that you need to match up the angle in the other triangle. So you do need to switch the order. So this is the other situation where the letters switch. It's either going to be the zigzag trick for the parallel lines or an overlapping triangles where one has been reflected like this. So those two situations are when you switch the order. And then this was the reflexive. That's what I was trying to get to when I wrote it too fast. So that's the reflexive property. And then why were the triangles congruent?
Side to side.
Okay? So the other way that I was showing you guys with the side angle side using the isosceles base angle theorem, you can feel free to do that too. And it's up to you to create it from scratch, but this is the other way that you would prove it with side, side, side. Alright, does anybody have any questions? Alright, so on your homework, it's completely blank. You guys can create them however you want to. You draw your own little grid or lines or whatever. I do have an answer key, but again, that's the way that I set it up. So just make sure all the steps are there. If they're in a different order, that's okay. And if you have specific questions, make sure that you ask me. Alright, we do have a proof quiz. It's going to be set up just like these were, like slightly filled in, fill out the rest. But that's the way that it's set up.